I did mention before that it's either going to be halfway between the real limits if you're using real limits, or it's going to be halfway between the boundary points if you're using boundary points. So I'll probably show you how you're getting the same thing, what your book is saying, and then what we can just use based off the graph that's here and onwards. Because the book says that because over here that you have real limits, but I also do know my real limits and I also do know my boundary points. So it's really your choice on what you want to do. It comes down to you. But anyways, let's go here and have fun calculating the midpoints real quick. So midpoint. And we're going to see method 1. For method 1, what your book does is, oh, let's get the lower limit of the current interval I want to get the midpoint for, which we're going to do for the first one, because I'm going to show you guys an awesome pattern, so we're going to constantly do it every single damn time. And over here, we're going to add it to the, lower limit, and we're going to add it to the upper limit of that particular interval, and then divide by 2. That's what your book says to do. So if I start with the first interval, it says that it's supposed to be 10 plus 24 over 2. And if you do this using order of operations, we're going to end up with 34 over 2, making it 17. But do we have to show all this work? Not necessarily. At least show this expression and see what it gets. We can use a calculator to do the rest of the work. That's what we're going to be seeing. If you have a calculator, make best use of it for efficiency. So what does method 2 say? Method 2 says that, so you can either look at the real limits of the interval or the boundary points of the interval. So it's really your choice when it comes to what, if you're doing boundary, make sure it's boundary. If you're doing real limits, make sure you're doing real limits. So in our book, we're primarily just doing boundaries, so I'm going to make it be the boundaries for right now. And therefore, I'm going to have the sum of the boundary point, or up here of the interval that we're looking at, boundary point, B, P, and divided by 2. That's what it says to do. So when I look at the boundary points for the first interval, the boundary point for 10 is supposed to be 9.5, so let's go 0.5 to the left. Same thing over here, I'm supposed to go 0.5 to the right because it's supposed to be the boundary point over here, beyond it. So plus 24.5 and divide this by 2. And the interesting thing here is this here still adds up to 34 and divides by 2, giving us 17. We'll still do the same thing. Let's do it by hand. Once again, do we want to do it by hand? That's up to you. At least you show the expression that leads to it, that's the most important part, and you put the rest in the calculator. Sometimes this might be a little nasty when it comes down to decimals and other stuff. So how do you put this in your calculator? Well, we're going to exit this, so we want to exit into the program. Just do second quit, which is the more button right here. So now, how do I get this fraction? Well, there's a shortcut that I want to show you guys that leads to it. Usually it's under math right here, but most calculators might not have under math. So the shortcut to doing it, most calculators should have, is alpha y equals. And it gives us fractions, the functions, matrix, and tables, or y bars. Okay? So we're here in the fractions, and we're looking at the n divided by d. That's what makes the fraction. You see right here, we're looking for the fraction notation. So I'm going to enter that. So now I have my fractions. So now I wasn't going to write the numerator, so we're looking at pretty much 10.5, or it's probably 9.5, if that fits. 9.5 plus the 24.5, I'm going to divide it by 2. Oops. Divide by 2. I'm going to enter it, I get 17. One thing you have to watch out is usually if it doesn't divide fully like this, and if it's fraction like this, it will be fraction setup. Okay. So I'm going to show you. You're going to see that happen soon, and I'm going to show you guys how we can convert. And therefore, sometimes the fraction will be useful, or the division operation using parentheses will be useful. But we'll see that in the future. But anyways, we have a point. So now we know for the first part, we know definitely that our midpoint that goes over here is supposed to be 17. So this midpoint corresponds to this interval. So therefore, this midpoint corresponds to this frequency. Let me bring it down a little bit. So, how are we supposed to be getting to the next interval? Well, once again, if you know your class interval, that's always we keep consistent. Because the lower limit is 15 away, the real limits are 15 away, the boundaries were 15 away. That means that the midpoint should also be 15 away. It's always consistent. That's why the interval size, or in our case, the class width, should remain always consistent. And we should know it. So if we do plus 15, we'll be getting a new number, which over here, it should be 32. And we just continue to repeat the process again and again. That's what's happening here. So, therefore, I come over here, and I'm going to do that. So, therefore, I have 17 already, so now let's go ahead and say plus 15. Enter it. Nice. Now, this plus equals again to repeat, because I'm going to do the same process over and over again. So, plus, plus, plus. So, we're definitely seeing here is the midpoint that falls between these boundaries, or this interval, is supposed to be 47. The midpoint that falls between these boundaries, or more like this interval right here, is supposed to be 62. And same thing, the midpoint that falls between these boundaries, or these intervals, is supposed to be 77. So we have the midpoints for each interval, but that doesn't happen to the polygon. Remember that. The polygon requires us to go one interval before the first interval and one interval after the last interval. So that means that literally I have to do one more addition of 15. Which we're going to find out is going to be 95, or 92, sorry. 92. And we'll see that. We'll put in a calculator. And this here is supposed to correspond with 0, frequency of 0. And over here, if I'm going the other way around, instead of adding, I should be subtracting 15. And when I do that, I end up with the midpoint of 2. And the 2 is supposed to correspond to 0 frequency. So you can do that calculator too. Get the same thing happening if I just add one more time, I get to 92. And if I do what I did before, and I say 17 minus the 15, I get 2. Nice. So that's good. So now we have all the midpoints that are needed. So now what I could be doing here is, first I'm going to show you guys is know how, once again, I kind of did myself and I forgot to show you how I could actually grab the histogram using the table, which we'll be seeing here. Okay. I can show you in the next film as well. But come back over here, how do we graph the histogram using the table, and also how do we graph the midpoint now, the polygon. So the first I'm going to do is the histogram. I'm going to show you, hey, we're going to do the same thing. But how do we graph the histogram? If we have this table already, if we have this guy and this guy, how do we graph the histogram? How we're going to do it is, first thing first, what we're going to do here, I have to do some labeling. And what we're going to say here is, to graph that, I want to get this interval, that's right here, which is my lower limit, and I'm going to let that be list 1. Oh, we have this one already, list 2. And just right here for these guys, for right now, for the histogram portion, we're going to let this be list 3, just for the histogram, because I'm looking at the histogram for now. I'm not looking at the midpoint sheet, or the polygons. So, that's what I'm going to do. So I'm going to go over here to the calculator. I'm going to go to statistics and edit. And list 2, I'm going to let those all be the corresponding lower limits. So we have 10, for that, 10, 25, 40, 55, 70, and that's it. Because we only have 5 intervals. The 85 is actually what's supposed to be, it's a real upper limit that goes to the last interval. Now the corresponding frequencies that go with them, it's supposed to be 6, enter, 7, 4, 2, 1. So get those enter. So now what we're going to do here is just looking at the table. Now that we have the lower limit corresponding to this corresponding frequencies, I can make a histogram. Because remember in the list, I said list and frequency. Now I could correspond to the frequency. So every 1 is going to be a list. I'm going to see that happen. So what we're going to do here is let's go ahead and go to second plot. And for now, I'm going to highlight 2, and I'm going to turn it on. So make sure it's flashing on, and you press on. And when you press down, it should be showing off. So come over here, I still want to grab a histogram. So therefore, I'm going to be at histogram, right here. And I'm going to make sure it's highlighted, and then press on. So over here, for this, it's not supposed to be this one, for the reason being, we said that our lower limit is here at list 2. So I'll make sure it's in list 2. And for frequency, we're going to make sure it's list 3 for now. So therefore, I change that list 1 to list 2 by pressing second 2. And I'll give on list 2. And over here is list 3, so I'm going to keep it the way it is. But if you needed to, all you do is press second and 3 to get list 3. So now I could go ahead and graph. I'm not changing the dimensions because it's going to be the same graph as before. We're going to notice how, when you look at it, the red is going to overlap the blue if the graph is big enough for you to see. So you see the blue, and then it follows with the red. And it's the exact same graph. So that's wonderful. Give it a table, I can graph the frequency of the histogram by looking at the lower limits, rescaling the windows to be consistent with the lower limits, its class interval, and the upper limit of the last class, and tapping in the frequencies, corresponding frequencies. Okay. So, when it comes down to this, usually when we do polygons, you're going to notice that it's not going to hit, and we have to hit polygons outside. So notice how it stops here and here. So that's why I usually don't use this as my standard grid, but the book does it this way. First of all, I showed it this way. What I tend to do, I go one more interval out this way, and one more interval out this way, assuming that if they existed, what would that have been? Okay. So therefore, what I'm really doing here is instead of having my x min to be at 10, I'm going to go ahead and go one more interval below it. So minusing 5 from it, or 15 from it, giving me -5. So I'm going to have my x limit start at -5, the x min. And when it comes to the x max, which was supposed to be 85 for the real upper limit, I'm going to add 15 to it to get one more to the right. This is what I typically do so I can get the histogram to be inside, and then I can also draw a polygon corresponding with it. And come over here, I'll do the same thing, and I'll put, when you add together, we end up getting 100. So that's what we end up getting. So, therefore, I'll put that into my windows now. And that's usually what I do all the time. I just go one more down so I could get the middle. So if I got the polygon at the same time, I can do so. So over here, it's going to now become -5. Well, over here, it's going to become 100. That's all it is. So now when I graph it, when I graph it, it's the same graph. I just have it be more in the middle, so now we can see the x-axis that's right here. So I can now get my corresponding scaling to work, and it looks easier that way because now we can see where the scale is and how it's really working versus it being zoomed in to the fitted version. I prefer this one a lot more because I can see the scales and I can see all kinds of good things when I do it this way. Well, if the scale is there, sometimes the y-axis might be a little too far out, but I do this way to help me out when I convert. And we can see how it corresponds. The same shapes here correspond to what I mean here. It has the same correspondence, if you notice it. So, now let's get the polygon in here. So now I get the polygon, we have to make new lists. So let's make sure we get this new list in here. So what I'm going to do is I'm going to pretty much erase this guy. Okay. Because now I'm going to have to use the full on list for the polygon. So what we're going to do here now is I want us to get the midpoint. And we're going to make the midpoint list. We use 3, so this will be list 4. And the corresponding frequencies to the midpoint, we're going to make that list 5. That's what we're going to do. So let's get those guys in here now. So once again, how do we quit this? Pretty much we do second mode to quit. And I could just go to stat, or you can press stat. Actually, stat would just got a little quicker. But it's just one more step. So in this 4, I want to pull out the midpoints, starting with the one before the lower limit. So we have to start at 2 and go on from there. So therefore, next one's supposed to be 17, followed by 32, and just put everything in there. 47, 62, 77, and beyond the last limit, or the last interval, is supposed to be 92. So we have that in there. So notice how this right here was original frequencies that was here at list 3. Okay. I could actually copy over here and make our slight adjustments. Since we're looking at the same list, so I don't have to rewrite all those guys in because they could be long and you don't want to make any errors. So how do I actually do that? How can I convert this list over to the other one? Well, I'm gonna be highlighted in list 5, so make sure it's black, and I'm gonna press enter. Then you say, okay, what do you want to do with it? What kind of list operation you want to do with it? Well, I'm going to say, just go ahead and give me list 3. Why don't you? Which were the original frequencies. And what it does, it copies it over. Isn't that amazing? But wait, we should catch on to something. Wait a second. I got 2, but what's that frequency 0? Oh, that 16 is supposed to go with the 17. So that means I have to insert a 0. So that's not bad. We can insert that 0. All we need to do is press a second, insert where 6 is. And there it is. My 0 has not occurred. So all I gotta do now is go down to the very bottom and put down 0. And enter it. That corresponds to the 92. So that's there now. So now all I do is I'm gonna graph this guy. I'm gonna use the third plot to do this. So therefore, I'm going to second y equals, and now I'm going to select the third plot and enter it. I'm going to make sure it's on, so it's flashing on, press it, enter it, so now when I go down, it's on. But over here, it's not supposed to be the histogram. It's supposed to be the polygon. Or in this case, it's supposed to be the XY line graph, which is right there, the second option. So make sure we press enter so that it's highlighted. And notice how when I press enter, it changed from list to frequency to being X list to Y list. But so don't be alarmed with that, because what we're seeing is the same consistency thing. Remember, this right here, the frequency was on the y-axis. This was your y values. Okay. Well, over here, the minutes right here were our x values. They're on the x-axis. So we're keeping consistent to what's up here. So x list should still be the measures, the x measures, or you say the variable measures, and the frequency should be the y's, keeping it consistent. So come over here, what I said before, that the midpoints, we let that be out 4. And its corresponding frequencies, we let that be out 5. So make sure we're going to change those up here to be appropriate. So therefore, come over here, I'm going to do second 4 to get out 4. And for the y, I'm going to do second 5 to get out 5. So they're there now. You can change the points in these guys you want. I try to make it as apparent as possible. But if you have two different graphs, I will change them so we can compare them. But I'm going to keep to the white, I'm going to do black. And therefore, I'm going to keep it the default black. Now, I'm going to graph. I'm going to see something nice. Okay. There's our graph. And it looks exactly like what we graphed over here. Exactly like it. And the points will be consistent, so if you want to check to see the points are good, and it's good to know that sometimes you might have different graphs. So, okay, what if I want to trace? Well, if you keep in mind, I have 3 graphs up there. So when I do trace, notice how the color over here is not black, it's blue, which says first plot trace. But I need to get to the second plot, I just press down, and now it's red. But I don't want the second plot trace, I want to do the trace of the polygon. So therefore, I have to press down again, and it's black. So the trace will correspond to the color you selected the graph to be, which is nice. So the color codes for you. If you have the colors, if you have the traditional silver ones, sorry, it's just going to be dirty green. There's no way you can determine that. And but look over here. Here could be a way to determine because here it says plot 3. So it's corresponding, red was plot 2. So it's letting you know what it is up here, and that's what you mean referring to here. I won't color code it, but the parent top gives you the plot type. Okay? So therefore, this is how we graph a histogram and a polygon, the corresponding polygon that deals with frequencies. Okay, and we learn how to get from data, and we also learn how to graph it from a table. Okay, 2 birds in 1 stone. So hopefully that was helpful, and definitely use it as practice. The more you practice, the better you get at it. The more you practice, the more efficient you get at it. Okay, so put that practice into use. It's very important.